We're going to take a look at a type of test that might be used in a doctor's surgery, a single point of use test, and it might be used for urine testing, for example. And these are the steps we'd take to make it. First of all, we'd formulate the special reagent, then we'd coat a long strip with this reagent. We'd test that media to make sure it was evenly spread and active. Then we'd cut that coated media into little strips and stick each piece onto the end of some kind of holder, like a lollipop stick. Then we test that batch again and pack them into cartons. So let's take a look at the operations model for that. This shows a volume of 5 million per year, a unit cost around 60 cents each. You'll notice that response time is very close to lead time, which means in this situation it's the time to manufacture that is determining responsiveness, not the period between batches. And on the capacity front, you can see that QC is the most used work center with a utilization of 87%. That's probably a little bit more than you would really tolerate. We'll have a look at this a little bit closer when we do some scenarios. The first thing we want to do something with is time and inventory. So let's go to the time and inventory input. First thing I'm going to do is to change that 2 months worth of packing raw material minimum stock. Seems a little bit excessive for a safety stock, so let's cut that down to 10 days. We're still taking deliveries every 2 months, but we can reduce the safety stock a little bit. Let's see what that does. That reduces inventory by about half almost. Then we want to do something with time. I'm looking at this number 5 here for QC test, intermediate hold time. This could possibly be because we need to do a microbiological test, which might take a little bit of time to incubate. So let's suppose we can do something about that and bring that down to 2 days. That takes some time out. It takes 3 days out to be precise. It takes 3 days out of lead time. It also takes 3 days out of response time. It also takes a certain amount out of work in progress because we've reduced the amount of product sitting around waiting to be finished. So that's one thing we might do. We've still got that QC utilization issue. So let's not look at time anymore. Let's put these back to where we were. Check we're back where we started and do something with cost. So a couple of things we might do with cost. One is reduce the time it takes to do a QC test. At the moment we're saying the changeover time for a QC test is 4 hours. What we mean by that is it actually takes 4 hours to execute the test, and it's regardless of the batch size. So that's why that is defined as changeover time, not as an items per minute figure. Suppose we could reduce that from 4 to 3. That brings some batch related cost out, and it takes a tiny bit of time out of lead time. Let's do something more. We've got this media coating process. We've got these long strips, which at the moment we're coating at 0.3 meters per minute. Let's suppose we could work out a way of doing that twice as quick. Turn that 0.3 to 0.6. Now you can see that we've reduced volume related cost, and there's a slight effect on work in process and a little bit more of an effect on lead time. You'll also see that by reducing the effort in QC, we've taken its utilization down so that the most used work center, the constraint, is now the cutter, not QC, and at a utilization of 64%, that's not bad. So these two scenarios are 30 and 31 from our book Bridge of Faith for Operations.